In the next question, he says that two connecting wires of same material and equal lengths and equal diameters are first connected in series and then in parallel in a circuit across the same potential difference. So the ratio of the heat produced in the series and in parallel combination. Now let's figure out something which you first should know, that here R, R is equal to rho L over A. As you can see, they have equal lengths. So we have length as equal and equal diameters. That means area is also equal, and of the same material, that means resistivity is same. So the resistance depend upon all these three factors, and here all are same. So we can say that resistance of both or the two connecting wires are equal. So R in both cases are same. Now, first, these two resistors are connected in series. So let's figure out how much is the total resistance. So total resistance, say if I use R dash in series, will be what? R plus R. So the resistance in series comes out to be 2R. And when they are connected in parallel, let's say in parallel, so in this case, let's say if I use 1 over R dash, as you know that in resistance in when parallel connected should be this. So this is what? 2 over R. So 1 over R double dash is this. So by cross multiplication, R double dash will be R over 2. So we got the resistance in case 1 and the resistance in case 2, that is in series and parallel. Now what we have to find out is the ratio of the heat produced, right? So heat produced. So what we know that ordinarily when I write using Joule's law, H is equal to I square RT. But check what we need to remember here, that what remains same across the same potential difference. So we cannot use this. Instead, we using substitution, which we can say that H is equal to V square by R into T. This is what you should remember, that we cannot use this relation here, as we can use this only when the current in the circuit is same, and when the potential difference across the circuit is same, we use this relation, right? So this is what we have to determine, but it's a ratio. So I can say that, say H dash as the case of first. Let's see, we have to get first series and then parallel. So H dash as series over H dash, S double dash as in case of parallel. So it's going to be what? V same here. So I can write V square over R1, R dash, sorry. As you can see that we have taken first in case of series, and this is for parallel. So I replaced H dash with using this V square R, V square T over R, and that divided by, for the other part in parallel, is going to be what? V square T R double dash. Now what you can observe that these get cancelled here. So if I look into the relation once again, what we get to see, let's check. So now we can write it here, that is, we got H here, H dash over H double dash will come as what? This is by cross multiplication. We can say it comes out to R double dash over R dash. Now if I replace this value, first we have R double dash, that comes out to be R over 2 from here, right? And replacing R dash from here, that is divided by R dash, divided by this is same as multiplying with the reciprocal. So 1 over 2R. This get cancelled. So 1 over 4, that is 1:4 should be the answer for this part. In this question, he says two connecting wires of the same material is same, so resistivity will be same, of equal length and equal diameter. That means length is equal and equal diameter means equal section of area, cross section area, are first connected in series and then in parallel across the same voltage supply, same potential difference. what we have to determine is the ratio of heat produced in series and in parallel combinations. Right. So first thing that I should see here that resistance is what rho L over A. So as you can see that there the material is same material, that means they have same resistivity, equal length means their length is equal, and equal diameter means equal cross section area. So this is clear that we have the the two connecting wires will have equal resistance. Now, next we have to find out the resistance in series and then in parallel. The ratio is like this. So what I'll do, let's say I partition the page here, and we'll first find out the resistance in series. Say I use R dash for series. Let me write on. This is case of a series and this is case of parallel. So in case of series, as you know that the total resistance, say if I use R dash, will be equal to R plus R. So that comes out to be 2 times R. And in parallel, it is 1 over R. I take R double dash. It should be what? 1 over R plus 1 over R. So 1 over R double dash comes out to be how much? 2 over R. And by reciprocating, I get R double dash as R over 2. Now, once we got the resistance in these two cases, what is next to do here is to find the heat, right? So what happens when I've seen that most of you apply H is equal to I square RT as the relation and obtain the ratio. That's not correct because you can see here the potential difference is same. You need to figure out that here the potential difference is same and not current is same. One more time, what you should see that the potential difference is same. So we can use this relation only when the current is same. So we'll be replacing this. So instead of this, what I'll be doing, I'll be using H is equal to replacing I. So it's going coming to V square R into T. Right. So this is what we need to get here. Now check here. If I obtain the ratio here using this, we are going to use this relation here. So what you can see that we have to obtain H dash over H, where H dash stands for the series and other for parallel. So V is same, I'll be writing V square, time is same, so time, and R will be R dash here. That divided by, next case, V is same, so V square T, and in resistance in series is R double dash. So you can figure out from here that these get cancelled, right? So this V square R are same. So on simplifying it coming as R double dash over R. Now if I replace these values from here, R dash can be replaced as what? R dash can be replaced with from here, right? 2R. And R double dash, okay, R double dash, sorry. R double dash is what? R over 2. And if you check for the other part, this is R dash, and how much is R dash? That is 2R. So dividing is same as multiplying with the reciprocal. So R get cancelled. As a result, we get 1 over 4, or it is 1 is to 4. So we'll say that 1 is to 4, that is C is the correct answer in this case. In the next question, it says two identical resistors, that means the resistance are same, of resistance 10 ohm are connected in first in series, as I can see, and in the second part in parallel in a line to a battery. That means voltage supply is same. This is something that you have to keep in mind, and the resistance are also same. So what we have to calculate is the ratio of power consumed in the combination of two. Now, when it comes to calculating the power, right, the first thing that we should keep in mind that P is equal to V square R, and P is equal to V square by R. P is equal to V square by R, and P is equal to I square R. Well, what you have to can see that here power is directly inversely proportional to resistance, and power is directly proportional to resistance. So there can be a confusion. So what you have to keep in mind, when V remains constant, we apply this relation, and when I remains constant, we apply this relation. As for the question, you can see we are given V as constant. As I told you while reading the question, that V is constant here. And that's why we'll go for this relation. Now let's first figure out the resistance in two cases. So in case one, that is in the first case, as you can say, they are connected in series. So I can say that the total resistance R is equal to R1 plus R2. As you can see, each resistor of 100 ohm. So I'll get the resistance as how much? 200 ohm. So this is the resistance in the first case when they are connected in series. Now, when these resistors are connected in parallel. So when they are connected in parallel, what we are going to get is the total resistance in this case. So I'll use 1 over R is equal to 1 over R1, which is 100, plus 1 over R2, which is 100 again. So that comes out to be 1 over R is equal to, that is 2 over 100. So that is 1 over 50. And on reciprocating, we get resistance in this case as what? 50 ohm. Yeah, that's 50 ohm. So this is the second case. Well, I use the symbol say R dash for series and R double dash for parallel. Now we have to calculate the ratio of power. So as I said in the beginning, we are going to apply this relation P is equal to V square over R, and not P is equal to I square R. So we have to find the ratio. By order, it has to be series over parallel, right? So by order, it is series over parallel. So I can say that series, as I said, P dash over P double dash will be equal to what? V square R dash for series, that divided by V square by R double dash. Now you can check from here that this get cancelled. That V square get cancelled. So by simplifying, it is coming as R double dash over R dash. And what is R double dash? It is 50, and R dash is 200. So I can reduce it further, and this comes out to 1 over 4. So the required ratio is 1 is to 4. That's how we will do this question.